Right, so welcome to our fuel system class, and of course when we talk about fuel system, we are talking about the system that make up the vehicle so it can operate. So basically the fuel that we use in motor vehicle is derived from crude oil, and crude oil is taken from the ground, then it is sent to a refinery. And in the refinery, the lightest part, which is the LPG. So like the forklift that we have out here, we have forklift that use LPG. We also have motor car that use LPG also. And then of course we have our gasoline now, or our petrol. But something to remember now, the gasoline that we get from the refinery would have to add either ethanol, MBT, Tulacen, or one time we usually add lead to the fuel to improve the octane ratings. And remember, octane means that how much heat and pressure the fuel can withstand before it actually burns and combusts. So when we get that fuel now, we'll put it inside our vehicle. When we put it inside our vehicle, now if I should look on our model right here, of course, we'll have a fuel cap, and this cap must be sealed, remember. So when you pull this cap, you're supposed to hear a pressure is released. If you don't hear the pressure release, therefore most likely you have a leak in the fuel system. So of course we have the fuel cap, then we have the fuel tank. Fuel tanks are made out either of metal, sheet metal, or they are made from plastic. And there are two methods used to secure the fuel tank to the vehicle. It's either we use a strap or we use a bolt. Then from the fuel tank now, of course, most of our modern vehicle nowadays, it will carry a pump in the fuel tank itself, or it will have a pump bolted up somewhere in the vehicle. But since we're going to focus mostly on gasoline now, we want to look on development over the years of the fuel system on motor car. So this component right here, which we call a carburetor, this was the first fuel metering device that we have. Fuel metering device. So this carburetor will comprise of three major components. Here we have the top of the carburetor, and always separated. Where you see these screws, this is the top of the carburetor. In the middle right here, we have the body of the carburetor. And if you should look closely, you'll see that this part of the carburetor right here and this part of the carburetor are different from this center part right here. Can you see that clearly? Alright. This part of the carburetor now is what we call the base of the carburetor. This part of the carburetor now, which is the base, that will be bolted onto the intake manifold. With this carburetor now, and for motor vehicle application, because carburetor is still widely used on like generators, weed whacker, some motorbike, and certain power machine. But those carburetors, they normally operate engine at single speed. So you know that like a generator will mostly run at single speed, a water pump engine will mostly run at single speed, a machine single speed. So those carburetors will use a single barrel. But for motor vehicle application, this carburetor has two barrels. The two barrel, we have a primary barrel and a secondary barrel. This barrel right here, which is a smaller barrel, is what we call the primary barrel. This barrel right here is a secondary barrel. Alright, there are certain key components on the carburetor that we need to identify and understand. Within a typical carburetor, we have some people call them jets, some people call them nozzle, and the American text will call it circuits. So the circuit tend to be easier to follow. So the carburetor now have a basic carburetor comprised of 7 circuits. People remember this, 7 circuits. Remember, I highlight to you the top of the carburetor, or some people call it the lid, the body of the carburetor and the base of the carburetor. The base of the carburetor comprises of two main circuits. Remember, we have the barrel, right? So the smaller one is the primary barrel. That's where you'll find nearly all of your circuit except for one. Primary barrel is where you find all your circuit except for one. The secondary barrel now is the big barrel. Look at this now. If you should look right here, we have two major circuits that is found in the base of the carburetor. And these are the idle circuit, or some people call it the idle port, and the off idle port. So should look right here, we'd see a port right here. Are you seeing this port? This port right here is what we call the idle port. So when the vehicle is idling, this butterfly valve right here, you see this thing moving? Can you see it? You see it moving? It is called a butterfly valve. Some people call it butterfly valves, or some people call it throttle valves. So these butterfly valves right here are throttle valves. This valve is what controls the amount of air and even fuel entering into the cylinder. But when the driver foot is off the gas pedal, of course this butterfly valve here is closed, right? So if this butterfly valve here is closed now, how the vehicle can still operate? The engine can only operate unless this port right here supply fuel or air, because some idle port it supply fuel and air. Can some carburetor to adjust the idle screw is one for the fuel and one for the air. And some idle screw just adjust the fuel alone because based on how the carburetor design. But the fact of the matter is when this butterfly valve is closed, this port is what supply fuel and air. So which circuit is the first circuit we can find in our base of the carburetor? Which circuit that is the what? Which one I just mentioned, people? I said the basic carburetor comprises of 7 circuits. And we said the base of the carburetor. We can find 2 circuits. And I just highlight one, which is the what? Yeah. Yes, but I said when this throttle plate here is closed and we need the engine to run CMA, this port is what port?
Idle port.
The idle port. Good. So the first one we established in the base is the idle. The second one now is that when we open this throttle plate now, or this butterfly valve, when we open it, we are seeing another port. Can you see it right here? Shine the light. Can you see this other port right here? This is a, you notice this port? This is the second port. Don't move. When I close it, you're not seeing that port.
Yes.
But when I open it,
yes,
you're seeing that port.
Exposed.
So this second port here is what we call off idle port or progression port. So in the base of the carburetor, we can highlight 2 ports with ease, or 2 circuits with ease. Is the idle and the off idle. Alright. So we established that on the base of the carburetor. The other component that we can highlight on the base of the carburetor is the throttle valves or the butterfly valves. And this is the throttle shaft. So where you have a throttle valves or a butterfly valves, you have a shaft to operate it by some form of linkage. Alright? So this is a primary barrel. The base of the carburetor now. We finish with the base of the carburetor. The body of the carburetor now, which is right here. If you should look right here, we'll have this connector right here. One would be a supply and one would be return. Inlet and outlet. So fuel would be supplied to the carburetor by what component? What component supply fuel to the carburetor?
The fuel pump.
The fuel pump. And we started out with this type of fuel pump. See it here? We started out with this type of fuel pump. And this type of fuel pump is what type of fuel pump? A mechanical diaphragm fuel pump. Mechanical diaphragm fuel pump. And the pressure for this fuel pump, what are we looking at? What range?
4 to 6 psi.
4 to 6 psi. Not going to get any other. 4 to 6 PSI and a diaphragm mechanical fuel pump. So this fuel pump right here now is driven by the camshaft, an eccentric lobe and the camshaft. And everybody know what a camshaft lobe look like, right? Yes. So when the lobe go in and out, it so it suck from the tank and supply fuel to the carburetor. So if you want to know which one of these is the suction, all you do is just move this and put your finger which one is the vacuum. Come, put your finger and find out which one of these pipes suck. Come, put your finger now, man. Put it on anyone now.
Hold on.
Are they one that suck?
Nah.
Put it on the next one.
No, I go on the same.
The vacuum.
Yeah, I feel some kind of
suction right here.
Yeah, man.
Alright, so this now will be sucking from the tank, and this will be now supplying to the carburetor. And even if you look right here, look on this arrow right here.
It always points to
Yes, you see it? Directional flow. So this will be supplying to the carburetor. Alright, and then this fuel pump, is an old pump, Back in the days, you could buy diaphragm, and overall this pump, And this pump, a pump like this still used for a modern day vehicle, Because for a diesel vehicle, inline pump, car pump like them here, to suck fuel from the tank and supply to the, so it's still used. Alright, and even the forklift out there, so it's a mechanical pump like this still used, Alright, and the forklift is a brand new forklift that we have. No, brand new forklift. Sorry. Alright, so here is the carburetor now. Here is the carburetor where we have the body. The body of the carburetor now comprises of also some other circuits. So I'm going to try to break it down for you. The body of the carburetor now comprises of a circuit that we call a float circuit. And the float is in this float chamber. You know the toilet bowl with that little float mechanism? So when the fuel pump supply fuel to this float right here on the body of the carburetor, when it full up, it closes up a valve that we call a check valve, and it stops fuel from entering into the carburetor. The check valve is right here. I don't know if anybody ever experienced a carburetor and fuel is coming out of these discharge nozzles.
Yes,
anytime fuel come out of these discharge nozzles, you just take something and knock right here so where the check valve is. In many cases, the check valve is not sealed properly. When dirt in there over a while, it causes the carburetor to flood. Alright? Yeah. No, brake cleaner really can't do the check valves. So the key component now, the float circuit, it controls the amount of fuel that come inside the carburetor, enter the carburetor. Alright? Then now, we have a little component right here. This is a rod. And what this is now, it's an accelerator, pump it operate. It's a pump. So when we step on the gas or leverage or linkage, yes. So when you step on the carburetor suddenly, it's the only circuit in the carburetor that squirt. Every other circuit in the carburetor depends on vacuum, suction. So when you step on this accelerator pedal suddenly, because when a sudden amount of air is coming into the carburetor, if that excessive air go to the engine can baffle, the engine can stall, the engine can die out, or the engine can be shut off. So you have someone when they usually drive them carburetor vehicle and they step on the gas pedal, they might go like they might try overtake and step on the gas, the engine bust a shot because the mixture lean, excessive lean mixture cause cylinder misfire or engine backfire. So this circuit now, so the other key circuit that is in the base, in the body of the carburetor, is the float circuit, which controls the amount of fuel that enter the carburetor, and the acceleration circuit that pump fuel inside the carburetor when the gas pedal is stepped on suddenly or aggressively. Everybody understand that? Alright. Acceleration circuit.
So, question,
yes.
Does this continuously squirt?
No man, it's just a one-off squirt, man. Because a pump, it's just like this. You notice, anytime I pump this up, it's just a one-off thing. So more time, I usually have a Suzuki Swift carburetor, you know. More time if I want to pick up some speed, and if I do it on the run, I just press my gas pedal hard or 4 times. Quick! You see when I do that, the carburetor goes, and then you see if you go boom. And if you look keen, you see some little black smoke come out of the tailpipe, can make it well rich.
Okay.
So it's a little way. You just 2 times and it's good to go. So the acceleration circuit. Alright. The top part of the carburetor now, or the lid now, we have a plate right here now. We should deal with cold start. Because you know, people, you see this carburetor right here, look at these 2 butterfly valves. This valves, you see this primary, this secondary throttle valves right here, these valves will not open until the carburetor. This butterfly valves are probably open about anywhere from 70 to 80%. So at that point now, the secondary barrel butterfly valves start to chip in. So throughout the life of the vehicle and the operation of the engine, the primary barrel, the primary circuit will be the circuit that working throughout the vehicle. So remember, we have a butterfly valves right here. This plate now, this plate right here, is what we call a choke plate. And the purpose of choke plate now is to deal with cold start. Choke plate. Alright? The choke plate now, the first set of choke plate we have some choke plate we call a strangler system. You remember them pickup van there when you go in it, and when the person started, them would have draw up and leave and try to start it, and then they release it down back. You know them vehicle there? And they might choke on it. You experience that vehicle, Sean?
Yeah.
It come like it's in the van.
Don't be disrespectful though, you know. Don't be disrespectful though, you know.
No man, not on the bonnet man. When you're inside, there's a lever that you can pull up. And when you pull up that lever, you might choke on it. And you start the vehicle and then you release it.
The Ford F1, yeah, and the Ford 100.
Ford 1R. So that lever that you pull up is this plate. It's this plate are you pulling up, you know. This plate. So what you're doing, you're technically closing this plate. So you can get a rich mixture. Because when vehicle cold, you want a rich mixture to start the vehicle. And remember, we talk about rich mixture and lean mixture and chemical correct mixture. 14.7 to 1, chemical correct. Rich, anything like 12 to 1. Rich or anything, and lean, anything over 15, 16, 17 to 1. So we talk about rich and lean mixture. So when you want a rich mixture, you make this choke plate close, so you have more fuel inside the carburetor to start the vehicle. So we have 3 types of chokes technically. We have some of them that are mechanically controlled with a lever. We have some choke now that actually work with coolant. So coolant actually go to the choke plate. So coolant will run to the carburetor or run to the throttle body and operate the cold start valves. And this now is what we call electronic control choke. So this one is actually
You work with ignition, right?
Electronic control choke. No, this one is not electronic control choke, you know, because I'm not seeing an electronical component. This is actually some mechanical control choke. Alright, but the choke circuit, it controls the choke plate. The purpose of the choke plate is to reduce the amount of air that is entering the carburetor so we can get a rich mixture. Alright? The other circuit now that we can find at the top is the low speed, low power discharge nozzle or discharge circuit, which is this nozzle right here. So look on the things that we find in the primary barrel now. We find the idle port in the primary barrel, the off-idle port in the primary barrel. We find the acceleration discharge nozzle or port or circuit within the primary barrel. We find the choke plate or the choke circuit within the primary barrel, and we find the low speed, low power circuit or low speed, low power discharge nozzle within the primary barrel. So the high speed, high power discharge nozzle now, that's what we find now in the secondary barrel. Alright? So I know I'm supposed to have a carburetor right here that is already disassembled, and here it is. So let me just quickly assemble it now, and what I'm going through now is components. Yes, and the components that we can see. So here we have the top, here we have the top, then here we have the body, and then here we have the, how many minutes to gone so far?
20.
20, alright. And then here we have the base. Alright, good. So here we have a carburetor that is partially assembled. So take off the top. Alright. Many parts missing from this. See the choke. This would carry electronic choke. Alright, see the choke plate right here. A check valve would be right here to fuel supply. Here is a fuel bowl. And light in the fuel bowl. I don't have the float. Check valves, yeah. And then right here now, you see this nectin right here? This is what we call the venturi or the venturi. And the purpose of the venturi or the venturi is to speed up the airflow. And if you notice, that's where, if you should look right here, so this discharge nozzle would be the acceleration discharge nozzle. So all of this you'll find in the body. You'll find the float. You'll find the float. Fuel bowl you'll find, and the float will be in the fuel bowl. The check valves will be right here. You'll find the primary barrel. I notice the primary barrel is smaller than the secondary barrel, and the nectin now it's what is the venturi. Alright, then now here now we have the base of the carburetor, and here it is. And if you should look on this carburetor right here, if we should look at this carburetor right here, if we should look, good. I don't know if you can still see the idle port. And if I should open it, you see the off idle ports. See the rest of the off idle ports? Alright. So, quick summary of carburetor. Quick summary of the carburetor, then we're going to move on to another one. The purpose of the carburetor is to mix the fuel and air into its correct ratio. Generally speaking, carburetor only designed to mix 12:1 fuel and air, fuel-air ratio. So the purpose of the carburetor is to mix the fuel and air correctly. A motor vehicle carburetor normally comprises of 2 barrels, which are the, can you remind the name of the 2 barrels please? Primary and secondary barrel. In the primary barrel, we can find the idle port, off idle port, can find the choke plate, low speed, low power discharge nozzle, acceleration discharge nozzle. If I should look down here, let me see if I can find the acceleration discharge nozzle. No, I can't see it from right here. The light is pretty poor. I can't see it from right here. But it is normally down in here, so in this section. Alright? And then now, this diaphragm now on the carburetor is what we call the dashpot diaphragm. The purpose of these vacuum and these diaphragm is to ensure that when you take your foot off the gas pedal, the throttle plate don't just close all of a sudden. You have some form of mechanism to make the throttle plate gradually close. Alright? So that is the purpose of these, some of these diaphragm and dashpot vacuum. Alright. So this carburetor now is what we call a fixed stroke, because the stroke cannot change. Fixed stroke carburetor. After we finish with the fixed stroke carburetor and motor vehicle application, we come on to this carburetor now, which they call the SU type, or it is called a variable venturi carburetor. Why it's called a variable venturi carburetor? Because here we have the piston. You see this piston moving up and down? They call it variable venturi, variable choke. Venturi, variable venturi, variable choke. And this carburetor now comprises of a piston. You see that piston moving up and down? So when the piston closes, no power. As the piston start to move up, more air start to enter. But when the piston move up, you see that needle, or you see that needle right there? The purpose of that needle now, as it rises, it starts to allow more fuel to come out of the fuel bowl, which is right here. So this carburetor now, if we should look carefully, Let us see the parts that we can identify, or the section we can identify in this carburetor. Right here we have the fuel bowl. Right here we have the supply and return. Alright. This portion of the carburetor will coming from, would have an intake duct would coming from the air cleaner. And this section of the carburetor will be bolted onto the intake manifold. So it will fit something like this on the intake manifold. So it fits something like this, and then we'll have the air cleaner over it like this. So this is how it sits. Alright. Fuel supply, fuel return. This particular system now, you remember we were talking about choke? This particular system now would have coolant hose coming to this. And then of course we'd have the electrical connector. Alright. Of course we have the throttle valves, or throttle plate, the accelerator cable will attach to right here. And when the accelerator cable attached to right here now, this section of the carburetor now, fluid normally in right here, so. And the purpose of this section right here is to prevent bouncing of the piston. So when it come up, when this piston here come up and come down, it come up and come down smoothly. So it will be similar to this dashpot diaphragm that we have on this fixed stroke carburetor. The variable venturi, so right here normal full of fluid diaphragm to ensure that the piston come up and down. Alright, when we finish with the carburetor now, the big issue with the carburetor is that it failed to provide a consistent amount of fuel over a long period of time. So we move on to this system right here. Anybody familiar with this? First time seen this?
No. Single injector.
Single pipe. Which vehicle is it on?
You can go on mostly Cadillac engines.
Cadillac. Alright. The Honda 1989 Honda Civics. Use a tractor body.
The same wedding, not even wedding, Demi Camera or something. It's on name or same Honda in the United States.
Yeah man, but I tell you one them in Jamaica. The 1989 Honda Civics come down with them here. The Volkswagen 1990 Polo come down with the tractor body, because this actually have a Volkswagen. The Toyota Camry prominent, the 1989, 1990, the long Camry, them. I remember the long Camry them are there. Tractor body injection they come down with too. 95, no man, multi-port man. Up here 1989, the Nissan pickup, the 1989. 1988, 1990, Nissan pickup, even once up in 1992, carry tractor body injection system. So them are the popular vehicle in Jamaica when they have these things for it. Alright? I understand that the Opel them did have it too, but I never really did familiar with the Opel in that. Alright? So this system now, it uses a single injector to spray fuel inside the intake manifold. And all this work now, we're going to have a fuel pump in the tank. But the fuel pump that we use at this tractor body injection would be of this type. What type of fuel pump is this? So I'm a two type we have enough. Electrical fuel pump. Good. And the PSI for the tractor body injection system will be approximately how much? Nah man, that's too much man. Check on the notes. I don't know what. 15. Good. Sound like a cash party you are playing. 15. So we'd have a 15 type PSI pump supplying fuel to the tractor body. Then right here now, we'll have a fuel pressure regulator. Want to see that?
The 15 PSI for the single.
Excellent.
Oh, okay.
You see with that paper, I tell you, you know, when I write something on the board, you know, it's a reason why I write them, you know. Because if you get a fuel pressure tester and we say, alright, you're going to measure the pump pressure, we're going to measure how much fuel. If you don't know what PSI you're looking for, what's the purpose of you using the gauge? You have to know. You have to have an idea how much PSI you're talking about.
So we're going to reference the gauge, right?
Yes, we can hook up a gauge on the Toyota Corolla around here.
Or what Benz?
So I heard
Benz are these.
I heard two different PSIs from 4 to
That's for the carburetor.
4 to 6 on
Diaphragm.
diaphragm mechanical.
diaphragm.
Yes. And we have to be specific, you know.
Diaphragm pump,
Diaphragm mechanical pump.
Diaphragm mechanical?
Diaphragm mechanical pump.
Alright, so diaphragm mechanical.
Because we have a plunger type pump, you know. We work on the GDI them and on the common rail them where high pressure them produce, you know, that driven by the camshaft too. So we have to know when we are talking about what we want. Because if you people if you don't know the things that we can't buy parts now, you know. You got other things online and buy the wrong thing. And when you come you can't fit, you know. So we have to know what the correct name of the something then.
So the diaphragm mechanical pump is
Yes.
46.
46 psi.
With the electrical filter.
Fuel injection.
Single.
For single.
Still full injection.
Single jet.
Electrical single.
Yes, electrical.
Electrical single injector.
Single point or people call it throttle body injection. So both names are set. Single point or single port injection or throttle body injection.
That one is 15.
15 psi electrical pump. With a fuel pressure regulator right here. Alright? But this system now, it uses a computer now to open the injector. I don't the engine management with you guys here. But it's just layout and the concept we don't want to know at this point. Alright? So you still have a fuel tank, you still have a fuel filter, you still have a pump. Fuel is supplied to the throttle body. It have a fuel pressure regulator, it go to the injector. The computer is what open the injector. Alright? So we start out with
Sir, carburetor is on that?
this? Yes. When it come on to carburetor still, you know, they try many things with carburetor, you know, before they phase it out, you know. So we have mechanical control carburetor. We all have computerized control carburetor, you know. We use duty cycle motor and all those things, you know, coolant temperature sensor and air temperature sensor, you know.
What in a full phase out?
Let me see if I can find out. This carburetor,
Water beauty.
computerized control carburetor, listener. See there?
Water beauty.
You see full of a connector, one connector, two connector. You see full of wire. See there? Solenoid right here, solenoid right here. The two solenoid we identify so far. This is the, we call this now, electronic control metering rod. Fuel cutoff solenoid right here. Electronic control idle, because this would control the idle. Electronic control idle. This now, electronic control choke. This control the choke plate right here. So we do them do enough things with carburetor before eventually them say, alright, here this carburetor thing that becomes stressful now. We can't, but and this you know can a computer, I say all them connector here would have go to the computer. So this carburetor now would have want like depends on things like coolant temperature sensor, air temperature sensor, and even O2 sensor. We try to make these solenoid operators best as possible. So them say no, too stressful. Alright, so now we move on to throttle body. Alright, so we leave the throttle body now as it's too stressful. Move on to this guy right here.
Multi-port injection.
We should call it multi-port. So some people call it multi-port or they call it multi-point injection system. And with this system now, you still use an electrical pump. Let's have another fuel rail. This fuel rail don't have a particular thing that I would like. If I don't have it, so be it. Alright, I'm not seeing the parts right here. Plus one replace. So this fuel rail right here, fuel rail, here we have individual injectors, and that becomes the big advantage of a multi-point injection system. We can monitor, ensure that each cylinder getting the correct amount of fuel. And this is operated by the computer now. And this is where the engine management principles start to come in now. So yes, you turn on the ignition, you still have a fuel tank, you still have a fuel pump, you still have a fuel filter, you still have a fuel pressure regulator, and all of these fuels go to the rail.
Yeah, it's gonna
The information now that comes to these injectors now, it comes from the cam and crank sensor. So the cam and the crank sensor now will tell the injector how to pulse. That's all the cam and crank do. tell the injector how to pulse. How long the injector will open now, that we call pulse width duration, or injector opening period. Pulse width duration now. It will depend now from the air temperature sensor. So if the air coming in the engine is too cold, that information will go to the ECU now, and the ECU now will extend the injector pulse width. If the engine is too cold now, you remember we talk about cold and we talk about choke plate. If the engine is too cold now with the coolant temperature sensor, that information will go to the ECU and it will increase the pulse width. If the driver now require more force, more load, more speed, if that information go to the thing what we call throttle position sensor, TPS, that information now go to the ECU and it increase the pulse width. If the vehicle now require more speed, the crank sensor now which measure the engine speed, that information go to the ECU and it increase the injector pulse width. So the ECU have a precise control. And then of course when the AC turn on, that information go to the engine and it increase the injector pulse width. When the vehicle is in D, that information go to the engine and it increase the pulse width, although that now gone out of engine management and then a powertrain management. So when you look and analyze it now, if you look at the basic generation of the fuel system, of course, we will start out with our double barrel carburetor, which comprises of the primary barrel and secondary barrel. Carburetor is still used on bike and power machine and generators and pump. Same similar component, but those systems are more constant speed. Then we move on to the variable venturi carburetor. We call it variable choke, variable venturi carburetor, or constant depression carburetor. Then we move on to a single point system, or what we call chuckle body injection. Then we move on to a multi-port and multi-point system. So when you look on the fuel system, just the fuel supply system, we've gone through technically 1, 2, 3, 4 generations. However, what I don't have right here, we have a system which was a mechanical fuel injection. I'm not going to go through that. That system was what we call the K-Jetronics, which used a mechanical fuel pump and it made the injector open constantly. And what veered the pressure now is there's a lever and a solenoid that inside a fuel control line that veer the fuel pressure inside. But we're not going through that because we're not going to see that nowhere, no shape, no form. Because we still have vehicle now. We still have some Toyota and some Suzuki Swift on the road now in the 1994, 1993 that still use carburetor.
95.
Up to a 1998 Toyota van, the Noah van, still use carburetor. Up to 1990. And then a Jamaica.
4-wheel drive model.
And the 4-wheel drive still use carburetor. Alright? This, you will see this on the Suzuki Swift, the 1990, the square one Suzuki Swift, but then come down with this. No, I don't see this on the hatchback one. Underuse this up to 1993, 94. Underuse this too. This SU type carburetor. Then now, talk about the injection. I mentioned the vehicle them earlier. The 1989 Honda Civics, the 1991, 92 Suzuki Swift, or what they call Geometro, because GM call them actually Geometro. The same Suzuki Swift them, same body shape, they call them Geometro. Use truck body injection. Under them, use it. This Nissan Pickup 1989 use it. The Toyota Camry 1989, the long one there, use truck body injection. How many of them you see on the road? And this now, this is the most common system. And what I don't cover and you can cover is GDI, gas direct injection. That is another system now where the gasoline is sprayed directly in the cylinder. So if we should look at the system, we can be able to label them and identify them and make a little sketch from them. Alright, so that's it for our fuel system. Thanks.
Like, subscribe, and share.
Do you think that we're